Hi, welcome to Physical Science. This is 3.3b on calculating mechanical energy. You're going to want to have your formula sheet ready for today. So to calculate EG, we must know three things: the mass, the gravity, and the height of the object. In order to calculate EK, we have to know the mass and velocity of the object. But remember, the law of conservation of energy says that if energy is not created or destroyed, it is just transformed. So knowing the total EG or EK at any position allows us to calculate information for every other position that we're given in a problem, because each location is equal to each other location. So EG, on your formula sheet, EG is equal to mgh. And EG is potential energy in joules, m is mass in kilograms, g is gravity in meters per second. And on Earth, that would be 9.8 meters per second. H is height in meters. Your equation alternatives, because we don't always just have to find EG. Sometimes we have to find mass and sometimes we have to find height. So mass is EG divided by gravity divided by height, and gravity is EG divided by mass divided by height, as if I put you on another planet. And height is EG divided by mass divided by gravity. Kinetic energy is 1/2 mv squared. Now remember your math, v squared means v times v. EK is the kinetic energy measured in joules. M is mass in kilograms, and v is velocity in meters per second. Your equation alternatives, because we don't just have to find EK, sometimes we'll have to find mass and velocity. M is equal to this 2EK divided by V squared, or divided by V divided by V. V, or velocity, is the square root of 2EK divided by M. So let's look at this calculation of this pendulum again. In the pendulum example, if A is 2 meters off the ground and the mass of the bob is 5 kilograms, we can actually calculate all the energies all the way through. Well, at least at positions A and D. So how much potential energy does the bob have at position A? EG is equal to mgh, mass times gravity times height. The mass is 5, gravity is 9.8, and the height is 2, giving us an EG of 98 joules. How much kinetic energy does it then have at position D? Well, in the energy equation, we would have written EGA is equal to EKD. That means the EK at position D is also 98 joules. Whatever you have in one position, you have in the others. So how fast is the bob moving at position D? Well, remember the velocity equation is the square root of 2EK divided by M. That's the square root of 2 times 98 divided by 5 gives us a velocity of 6.26 meters per second. The bob is moving at 6.26 meters per second.